All right, excuse me. We're in now section 1.2, which deals with the powers of math, or exponents, which would be a better term. Um, you may have seen this before, and this is an example of a exponent expression. I have some arrows pointing at certain numbers. I have what is called the base, and that's pointing at the 5. And I have what is called the exponent, which is pointing at the little 3, which is posted at the top right of our base. And what that means is the base, whatever value that may be, we're going to be multiplying that number several times. And the exponent value, which happens to be 3, tells you how many times you're going to multiply by that same number. So 5 to the third power, which that's how it's written in words, 5 to the third power means that we're going to be multiplying 5, 1, 2, 3 times. And when you do that, it ends up becoming a value of 125. It also works for variables too. So say if we had a variable of b, and we're going to be multiplying it by, or we're going to be taking it to the 4th power. Now, standard practice has taught us that the multiplication symbol is like an x. But what we talked about in section 1.1, x could be a variable. So I want to try to get you out of the habit of writing multiplication as an x value. I want to start using the dot. So I want to see us write multiplication more like this. So it's b times b times b times b, saying that we have a base of b, and we're going to multiply that same value 4 times. Okay? So if we take a look at the examples, it's kind of the same thing that we were doing before. We're going to evaluate the expression, which means that we're going to solve the expression, which is a math problem without an equal sign. And in this case, we're going to use n for 2 different values. N could be 8, is going to be 8, and also n is going to be 0.3. So we're going to use that for both, for all 3 of those problems, 5, 6, and 7. So technically, we're going to do 2 problems per number. So the first one, it's the same step as we did in section 1.1, is we're going to replace that number with the variable. So I'm just got n is 8, so I'm going to say a squared, and then the second one is going to be 0.3 squared. This means that it's going to be, the base is 8. We're going to multiply it 2 times, so it's 8 times 8. 8 times 8 gives me 64. Here it's going to be 0.3 multiplied by 0.3, and this becomes 0.09. For 6, it means we're going to go 8 to the third power, and also we're going to go 0.3 to the third power. That means it's going to be 8 times 8 times 8. This one's going to be 0.3 multiplied by 0.3 multiplied by 0.3. Now what we talked about in class is it's best to multiply 2 values singularly. So like that just means, like, let's take 8 times 8, we know that's 64. Then now we take 64 multiplied by 8, and that gives us an answer of 512. We can remove many mathematical errors by just multiplying 2 numbers at a time. Same thing goes for here. This is going to be 0.09 multiply that by 0.3, which then that equals 0.027. Okay. Same thing goes here. I got 8 to the fourth power, and then I got 0.3 to the fourth power. Again, this is going to be 8 times 8 times 8 times 8. Same thing goes for here. For 0.3, we're going to have 4 of them across. If I multiply all these together, I get 4,096. And then if I take 0.3 to the fourth power, I get 0.0081. Here, this says write the power in words and as a repeated multiplication. Then evaluate the power. So it's kind of like using words. So this means it's going to be 9 to the 6th power. Okay? That means that this is going to be 9 times 9 times 9 times 9 times 9 times 9. So 1, 2, 3, 4, 5, 6. I got 6 nines. And if I were to evaluate it, that means solve. And if I were to multiply all those together, I would get 531,441. Okay. Here would be 2 and 5/10 to the fourth power. Oh, I'm sorry. I write in words. My apologies. So that means it's going to be 2.5 times 2.5 times 2.5 times 2.5. And doing all that math, that comes out to be 39.0625. Okay. Looking at this, this is just more of the same with the expression, but they give you an x equals 0.64 and y equals 15. So make sure you keep that in mind. But as you look at questions 15, 16, and 17, it all deals with x. So the only numerical value you're going to be dealing with in this case is 0.64. All right, so for this one, it's going to be replacing the number with the variable 0.64 to the third power. That means 0.64 multiplied by 0.64 multiplied by 0.64. Multiplying all those together, I get 0.262144. If I look at number 16, it's just going to be 0.64 to the second power. That means I'm going to go 0.64, multiply it by 0.64. 1, 2. That's where the 2 comes from. And then doing this, it becomes 0.4096. I'll start with this one too. The last one is, we'll make it 0.64 to the first power. When you see something to the first power, all you're going to write is 0.64 one time, and there's no other application, so we just leave it as is. So technically, 0.64 to the first power is the same thing as writing just 0.64. Okay? Last thing we're going to talk about is area and volume. They correlate with the exponents very well, because when we're dealing with the area and volume of a square or a cube. And the definition of a square is all sides are equal. So for 21 and 22 in this case, if it says 17 inches for one side, that means it's 17 inches on all 4 sides. Same thing goes for 22. If it's 22 feet, that means it's 22 feet on all four sides. If we remember, area of any type of rectangle is length times width. But when we're dealing with the area of a square, we can use powers, which means it's whatever value you're going to give the length is. So 2117 for 22, it's 22, and we get to square it. So for 21, for instance, the area of this square is going to be 17 squared, which means it's 17 times 17, and that gives me 289. Now, since there's a label here, and we're dealing with area, it's going to be labeled as squared inches. So you're going to have the inches, which is what it's labeled here, and then we're going to put a square on that, just like we did to the area of whatever distance it is. We squared the number, we're also going to square the inches. Same thing goes for 22. We're going to go area equals 22 squared. 22 times 22, oh shoot, 22 times 22 gives me 484 square feet. And that's how it's labeled. So that's 22, and this is 21. Last thing we're going to talk about is volume. So standard equation for volume of a rectangular prism is length times width times height. But characteristics of a cube is all sides are equal. So if this is 0.09, that means the distance from here to here is, or I'm sorry, 0.9. The distance here is 0.9, and then the distance from here to here is also 0.9. Which means that the volume of a cube has its own specific definition as well. So then the area of a cube, or excuse me, the volume of a cube happens to be whatever the distance one side is, and we're going to cube it, or use it to the third power. Okay? So for 25, I have volume equals 0.9 to the third power, which means that's going to be rewritten as 0.9 times 0.9 times 0.9. And then this is going to be written as 0.729. And then just like we did with the square inches and square feet, we're going to write this as cubic yards. So it's going to be yards cubed here. For 26, we're going to go volume equals 1.3 to the third power. 1.3 times 1.3 times 1.3 gives me the value of 2.197 cubic feet. And that is being able to use powers and exponents. Hope this helps. Until next time.